Okay, so today we're going over electron configuration and orbital diagrams. Now, you basically got the notes yesterday, but I kind of want to go over it today. So you have hydrogen, it's one electron. What you have to do is you have to start off with this very first box, which is 1s. And inside of these boxes, it can hold 2 electrons, kind of like the houses did in that worksheet that we did before this. So since this one only has 1 electron, you're going to do 1 half arrow going up. Now when you go to write it, it's 1s1 because you do the title up here, 1s, and then you have 1 electron inside. So you end up with that. Then you have helium. It has 2 electrons, but they can't be the same direction because of Pauli exclusion principle. It says that they have to have different spins if they're in the same box. Well, remember, you got to fill this first box first before you go on. So you have an up arrow and then a half down arrow. So that's 1, 2 electrons. So when you write it, it's 1s2. Then lithium has 3. So we filled this guy, and now we can add to the next block. Okay? So we have 1 up, 1 down, 1 up. Now this right here is a shorthand notation for helium. Helium is 1s2. Instead of writing this every time, we can just sub in helium. So this time we didn't have to write down that. We did helium. And then we have S2, 1. So helium, S2, 1. Now the longhand formation would have been that, but remember we subbed this guy out for helium. Okay, for beryllium we got 4. So we have these 2 boxes and it's up, down, up, down. And then we have helium and it's 2s2. This is 5, so we finished this one, so now we start on the 2p. We just have 1. Now when we advance and go on, you cannot double up in here. When there's 3 houses like this, you have to put an electron in every house before you can go back and double up. Okay, so 1 in each house first before you can double. So it's 1, 1. Okay. Now this is known as Hund's rule. Hund's rule says that they like to be separated and that if they they want to be in the separate orbitals within the same orbital group.